Okay, let's look at question 7. The students and teachers at the school record the time it took for them to travel to school. The box and whisker plot shows the distribution of the results. Okay, so you have teachers on top and students at the bottom. This is your very typical box plot. Question part 1 asks, there are 18 teachers who took more than 50 minutes to travel to school. Work out the number of teachers in the school, so total amount of teachers, right? So if you look back at the graph, where is 50? 50 will be in between 40 and 60, right? So here must be 50. So let's just look up where is 50. I'm looking at teachers, so I'm looking at the top box plot. I'm not looking at the bottom one. So this is my, actually this line. It hits this line here. Okay, so this requires your understanding of box plots, right? So maybe just a recap, what is a box plot? This line is my minimum. The line all the way at the highest point, this is my maximum. Okay, so I think minimum and maximum quite simple to get. This one is actually your median. This line in the middle. This one is your Q1. And this one is actually your Q3. So that is what all the lines mean. Okay, so recap a little bit if you are a bit lost. So Q3, that means my at 15 minutes, right? At 15 minutes, this is my Q3. And what is Q3 actually? Q3 is actually your 75%. Okay, so the third quarter is 75%. So at 75%, I have 18 teachers. Okay, all right. So if 75% is 18 teachers, can I work out then what is 100%? Okay, my bad. There are 18 teachers who took more than 50 minutes. Okay, more than 50 minutes. So up to here, from your minimum all the way up to 50 minutes, right? This is your 75%. Okay, so the teachers who took more than that is actually from here all the way to here. Can see? So it's not very proportionate to the number, but it's understanding, right? So instead of 75%, Q3 is 75, but who took more than that, right? If they said question said that it's less than 50 minutes, then yes, 75% sure. Okay, but if it's more than that, it will be 25%. So that means 25% of the teachers took more than 50 minutes to travel to school, and that 25% is also equivalent to 18 teachers. Okay, so same concept, I still need to find out what is 100%. So 100% would be 18 times 2, you get 72 teachers. Okay, 72 teachers. Okay, next I need to make a comment comparing the averages and a comment comparing the distribution of the time taken by the students and the teachers. Okay, so the question very nice already. They tell you what they're looking for. They're looking two statements, one for averages and one for distribution. Okay, so let's look at the average first. Okay, so over here, average you would think it's mean, right? But because just now I said that the box plot, right? This middle line here, this is not your mean, this is your median. Okay, so if you recall, median is the middle guy, okay, sort of the middle. Okay, so exactly in my plot, right? Who is the middle guy? Who exactly is in the middle? Okay, so if we compare just by looking at this line, teachers are over here, right? Teachers are this line over here, and students is this line over here. Okay, maybe I can find out what exactly is the number. Draw this down, this is 36. Okay, down, this is 24. No, this is 28, sorry, 28. Okay. Okay, because yeah, middle is 30. Okay, so 28 and 36. Right, so based on these two numbers, you can tell who is bigger, right? So the teachers, the median for teachers is higher. Okay, so make a comparison. They ask for a comparing, so you have to compare. You have to say who is higher or who is lower. Okay, so median for teachers is higher. You can say at 36 minutes. Okay, compared to students, right? So every time they give you data, you are free to use the data, right? So use the data and get your marks. Okay, so if you don't quote your data, I mean, can, but it would be nicer if you quote your data, right? Because it's already given to you. Just use it, okay? At 28 minutes, okay? So what does this tell you? If the median, we spell it out nicely, median, okay, median. Okay, so what does this tell you? It tells you that on average, the teachers took longer time to travel to school. Okay, since their median is higher. Okay, so that is all, right? You can tell based on their averages that the median for teachers is higher. So it means that on average, more or less, they roughly take a bit more time compared to the students in order to come to school. Okay, next I need to compare the distribution. Okay, so distribution, there are two ways you can do so. You can do it with the range, which is basically your maximum minus the minimum, or otherwise, you can use something called the IQR. Okay, interquartile range. Okay, so interquartile range. And what is IQR? This one you have learned before. It's actually your Q3 minus away your Q1. Sort of like a range, but between Q3 and Q1. Okay, so maybe let's try to work out IQR. That range is quite simple. It's just max minus mean. Let's try the tough one, right? IQR. So how do I find IQR of teachers? I will take Q3. Q3, I know it's 50. I know it's 50, Q3 minus Q1. What is Q1? Q1 will be this point over here. Go down, you get 32. Okay? And you get 50 minus 32, you get 18. So that is the IQR for teachers. Okay, do the same thing. Oh, sorry, can you see? Yeah, okay, so do the same thing for the students. So Q3 minus Q1. Over here, students Q3 is this number over here, so 34 minus away 16. Okay, you also get 18. Seems like both of them have the same IQR, right? Both of them have the same IQR. So what does that tell you? Right, it tells me that actually their travel time, the consistency of their travel time is about the same. Okay, so maybe let's write out whatever we know so far. So IQR of teachers is 18. Okay, how did I get 18? Show you're working. So 15 minus 32. Okay, and the IQR of students is also 18. Okay, same thing. How did I get 18? It's because, okay, I'll write it here. 34 minus 16. Okay, so what does this tell us? This tells us that since both have the same IQR, the consistency of their travel times is the same. Okay, so yeah, so that's all. This is how you compare the distribution of the times taken, okay, by the students and the teachers. Okay. Okay, let's move on. So part B. In a class of 24 students, 8 walk to cycle, 8 walk to school, 6 cycle to school, and the rest travel to school by bus. Okay, so straight away, there's only 3 options, right? It's either you walk, you cycle, or you take the bus. Okay, so in a class of 24, I can find out how many take bus, right? I will say that it's 24 minus 8 minus 6. Actually, this is my answer for part here lah. Okay, let me see here. So question wants you to find the probability that the student travels to school by bus. Okay, so I need to find probability, It would be number of students who take bus over total number of students. Okay, number of bus and students. Okay, so number of bus, easily I can find that, right? It's 24 minus 8 minus 6 over 24. That is my total number of students. Okay. Okay, this in, you get 10 over 24, simplified, it's 5 over 12. Okay, so 5 over 12. So for probability questions, right, you can leave your answer in fraction, or you can leave your answer in decimal place as well. Okay, up to you. Fraction would be easier to do, to see also lah. Okay, next, 2 students are selected from the class at random to find the probability that they both use the same type of transport to travel to school. This is a very common question. How do I even approach this? Maybe I can start by drawing something. Okay, so I can't visualize, right? I can't visualize anything. I'm a visual learner, so I need to draw everything up. So I know that total, I have 24 students. Okay, total is 24. If I pick I know that 8 walk to school, I know that 6 cycle, and I know that how many is left? It was 10, right? 10 take the bus. Okay, because 10 plus 8. Yeah, okay, so 10 take the bus. Okay, I need to find, okay, so when I do the graph, the plotting of the probability tree, right, I have to be strategic as well. I need to find that both use the same type of transport. So if let's say I pick the first guy, he walks to school. If I pick the second guy, he will also need to walk to school. Make sense? If he walks to school, now it must be 7 walk mah, because I'm taking one up. So now my new total would be 7. In order to get this, it would be 7 over 23. Okay, maybe I'll replace this. This is 8 over 24. This is 7 over 23 walk. Okay, so how I get 7 over 23? Because 8 minus 7, no, 8 minus 1, I get 7. 24 minus 1, I get 23. Why minus 1? Because I already took out one student, ma. I took out one student, so on top must go, below also go. Okay, do the same thing for the next one. So next one was cycle, right? So C, my C look like L. Okay, so C, if I took out one student who cycle, this will be at the start is 6 over 24, right? If I take out another student that cycles, it will be 5 over 23. Same concept, just minus and minus. Okay? And then same thing for the last one. So bus, right? Bus would be 10 over 24. If I take bus again, it would be 9 over 23. Okay? So how to find the probability of this whole thing altogether? I will need to find 8 over 24 multiplied by 7 over 23 because I'm going into the node, right? If I'm going into, I need to multiply. Okay, so this is my walk, then plus 6 over 24 multiplied by 5 over 23, this is my cycle, plus my 10 over 24 multiplied by 9 over 23, this is my bus. Okay, so key all this string of numbers into your calculator. Final answer you will get is 22 over 69. Okay, so you can leave your answer in fraction, it's fine as well. 22 over 69. Okay, let's look at part 3. So 3 of the students are selected from the class at random. Find the probability that 2 of them walk to school and the other does not. Okay, so it's very similar to the question above, but now it's instead of 2 students, it's 3 students. Okay, so what can I do? Maybe I can try and work out my probability tree first. So, okay, so we have to be strategic about it. So let's see, the number of walkers. At first, I had 8 out of 24 walkers. Make sense? And if I have 8 out of 24 walkers, so that means that I have 2 options to go. If I choose the next student, it could be that they also walk, and then the last one don't walk. Okay, non-walker. Let's put it as non-walker. Okay. Another option is that I can pick from here and I can choose the second guy to be the non-walker and the third guy to be a walker. Right, so I just swap the positions around and it still fulfills my criteria, right? My criteria is just that at least two of them needs to walk to school and the other does not, right? So if I look at the first scenario over here, walker, walker, then non-walker. Can write 2 walk, then 1 don't. Walker, non-walker, walker. Can see? So total, I still have 2 walkers, I only have 1 non-walker. Makes sense? So over here, it's a bit more tricky. I need to be strategic about it, okay? And how about the next one? So, if I have 8 out of 24 walkers, I can easily say that 16 out of 24 must be my non-walker. And actually, who is my non-walker? This is actually made out of your B plus your C. So what is B and C? It's your bus and your cycle people, right? So how did I get 16 actually? It's from these 2 numbers, right? I know that cycle, there's 6 out of 24 students. I know that people who take bus, there's 10 students, right? So 10 plus 6 are 16, and both of them do not walk. So let me just put them together. Okay, so 16 over 24. Okay, so once in this scenario, I only have one way to go, right? Because this one, it's my non-walker. Can see? So my next 2 option, it must be a walker and it must be a walker. Makes sense? In order to fulfill the criteria, right? If you see here, I need 1 non-walker, 1 non-walker, right? 2 of them walk. So the next 2 must be walker and walker. Okay, so this is what should be going on in your head, right? This is the probability tree, like that, like that, like that. Okay, so draw everything. Okay, so work out what do you actually need to find. You don't have to find every single thing. Okay, just work out what is important. Okay, so let's look at maybe the top part first, because that looks a bit challenging. So yeah, if I take 8/24 walkers, that is my first student. Okay, then my second student, if same thing as just now, if I take one student out, it would be 7/23. Does that make sense? Because I take out one student from the walker ma, so instead of 8, it would be 7. My total number of students also decreased by 1, so instead of 24, it would be 23. Okay, now the next part, my third student, now it's a non-walker. Okay, so non-walker, the denominator, same thing. I took out one more student from my student number 2, right? My denominator, my bottom number must be 22. Make sense so far? Because 23 minus 21, you get 22. Okay, I take out one student. Now, what number do I put at the top then? It's non-walker, right? Non-walker at the start. It was 16. It has always been 16. I didn't take any student from the non-walker, so this stays as it is. Okay, so 16/22. This is the two numbers, this number that I need for the non-walker. Okay, that is my first scenario. Next one, I'm going this way now. So at first, I still take 8/24. Then now I'm going to non-walker. Then I'm going to walker. Okay, so non-walker, same thing. We found out, we know that it's 16, right? 16 students. Let me write that down nicely. It will be 16. And the denominator would be 23. Because I'm taking one student out from my first guy. At first, I have 24 students. I take out one, I have 23. Okay, and my non-walker is 16, so 16/23. Okay, then my walkers. How many walkers will I have now? Okay, denominator, I know it's 22 because same thing, I took out one student, so one student will be 22. So the walker, now at the start, I had 8, correct? I took out one walker. If I take out one, it would be 7. Right, so 7/22. Does that make sense so far? Right, so as I'm moving from student 1, student 2, student 3, right, it's always a decrease of 1 because I'm only taking one student at a time, right? Okay, then the last scenario, I start off with non-walker, so 16/24. Then I choose a walker next. So if I choose a walker next, it will be 8/23 because I didn't touch my walkers at all, right? So 8/23 because 24, I took out one, right? So it's 23. Okay, the next one, I take another walker from this fella over here. I take another walker, right? So it will be 7/22. Does that make sense so far? Yeah. Okay, so now we know all our numbers. We need to put them together. So to find the overall probability, it would be your first scenario, which is 8/24, multiplied by 7/23, multiplied by 16/22. So what is this scenario? This is my walker, non-walker. Okay, that is the very first scenario. Then next, I'll add the probability of 8/24 multiplied by, okay, put this down. Okay, 8/24 multiplied by 16/23 multiplied by 7/22. Okay, so that is my second condition, right? 8/24, walker, non-walker, walker. Okay, walk, non-walk. So still fits my criteria. So yes, these are the 3 numbers that I need. And my last condition, it will be plus 16/24 multiplied by 8/23 multiplied by 7/22. That is my third condition, whereby it's I start off with non-walker, then walker, walker. So non-walk, walk, walk. Okay, whole string of numbers, very, very long string of numbers. Just key into your calculator. Okay, so key into your calculator, you will get 56/253. Okay, so 56/253. This would be your final answer. Okay, so for probability, you can leave your answer in a fraction.